This is an attempted walkthrough of the full rig calibration. First, I'm going to calibrate the cameras, and I'm going to select the data it's on C. It's in working data. And this is the TIFF files. So I made sure I've got the right file name and folder name following the appropriate naming processes. Now I've got the TIFF file, which has been converted by the camera system. Calibration will be saved to, so that's where it's going to go. It's going to program data, 3D imaging. It should come up. Here we go. So we've got 1 through to 42, which is good. That looks clean. 1 through to 42, all the corners look clean, nothing else. 1 to 42, everything looks, that's a bit wibbly down that end, but that looks much better. 1 to 42. These are all the same face, same grid, just different areas, different perspectives. And there is a requirement to include some rotation. Now this is going to tell me the calibration RMS, which is 0.278, which is pretty cool. So I've done that, the calibration file's been written. Next step is to calibrate the rig, which is the collection of cameras. Before running this program, the camera must have been calibrated. Yes, so we've done that, so we can open it. Takes us to the right file, picks up 210325, which is today's date. Tell it to take that now. It's going to ask, it's asking me for the photos to use again. I'm going to local working data, rig calibration data, and again I'm selecting the TIFF file folder. Okay, select each image pair. Select the symmetric image of the first of the pair first, then select the second image of the pair. So what I'm going to do is I'm going to start, and from my point of view, I always look for the green one on the left. Now there's two images with each of these ones. This one here is symmetric. In other words, this side is the same size as that side. This one here is not symmetric, so I select the symmetric one first. I've selected the first, now I select the second one in that pair. Now select the symmetric image of the second pair, so I'm going to look for the two dots on the left hand side, and that's that here. I've got one here and one here. That is the symmetric, that is the asymmetric, so I select that one and then that one. Now I'm going for the third pair, so I'm looking for 3 dots. 3 dots is blue. Here they are. I'm picking the symmetric one and then the asymmetric one. Now for the fourth one, that's the yellow dots. They're harder to read. Now, which one is the more symmetric? That one and then that one. They're not always in the same order. Gives me now a review. 1 dot, 1 dot, 2 dot, 2 dot, 3 dot, 3 dot, 4 dot, 4 dot. Okay. Each of the symmetric ones should be at the top and the asymmetric ones at the bottom. That looks good. I'm pressing enter. Okay. Grid 1. So this is grid. So this is what we want. We want it to be grid 1. This allows it to move and to select other grids, but we don't want that. We don't want grid 0. We want grid 1. Now, the selection we need to make is in relation to one of these panes. So we're going to pick the first pane. We're going to mark the top. Oh, sorry, apologies. We've got to go enter first. Now we've got to go to the top left and the bottom right of that pane. And it says, hey, yeah, is it this one? Yes. So I'm pressing enter. Use a selected grid. Yes, I'm pressing enter. Select the top left and then bottom right of the reference grid for this image. So that's the asymmetric one. That's the other one. So top left, bottom right, got a green box, pressing enter, use the selected grid, OK. Waiting. Processed images corrected for distortion. The red is on the reference grid, so that's the red, and then so they've got 142, 142, 142, 142. So all the right dots are there. I think that looks good. I don't really know what I'm looking for here. Okay, so I've got grid 2, so I'm happy that grid 2 is the right number because that's 2 dots here on the left. Don't point with your finger. So I'm going to select the top left and the bottom right. I'm going to confirm the grid, select the top left, the bottom right. Again, I'm going to confirm the grid. Now it should show me the dots again. One 42, 142, 142, 142, red, purple, purple, red. I'm not sure why they're opposites insofar as that's red, but probably because that's the asymmetric. No, it doesn't make sense. Okay, so this is grid 3. I'm happy with grid 3 because I've got 3 blue dots on the left-hand side. Selecting the top and the bottom, saying yes, yes. Selecting the top and the bottom, saying yes, yes. And now we're waiting. Okay, so they're the processed images, 142, 142, 142. I can see coloured dots, they look like they're on everything. So I'm pressing enter. Set the grid number for the reference grid using the track bar, then press enter. I'm happy that that says grid 4, that's what I want. I've got 4 yellow dots, now I'm going top left, bottom right, accept, accept, top left, bottom right, accept, accept. Now that's the 4th and final, so it's off doing its business. We've been running now for 7 minutes and 48 seconds. Okay, so 142, 142, 142, they all seem to be good. I've just got the right numbers there, so I'm pressing enter. Okay, here we go. Calibration data recorded. Average corner to corner distance is 0 dot dot minus 2147, blah, 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 blah. They look pretty close. Now I'm guessing. Anyway, we'll go and look at that file. I can't copy it. And I've forgotten already where the file was. Okay, I've gone through the tedious process of working out where the file gets saved to. And I've got this file here, TBS, rig calibration data, today's date, XML format. It's a 66 kilobyte file, so it's not huge. Oh, I hate this. No. All right, so what have we got? So they're all the values for the 42 points. Camera parameter, image coordinates. I'm simply showing this so you have an idea of roughly what the file looks like. I'm not doing it for any other purpose than demonstration. I don't for a minute pretend that I know what any of this means. But gives you a reasonable idea of the size of the file and what the content is if you need to sense check anything. Now it's just a series of coordinate numbers, I presume relating to points and the changes that they need to make on the fly. It's quite bloody amazing. Okay, and that is the end of my walkthrough.